In today's lesson, we're going to investigate populations and sampling. A population is a group of individuals or objects that you may want to study. If a population is too large for data to be collected from every member, you will need to collect data from a part of the population. This smaller group is called a sample. When choosing a sample, there are a couple of things to keep in mind. First, your sample must be completely random. Okay, make sure that your sample is completely random. In a random sample, every member of the population has an equal chance of being selected. This means that the sample is representative of the entire population. The second thing to remember when choosing a sample is to avoid bias. You want to avoid bias when you're choosing your sample. A sample is biased if some members of the population are more likely to be chosen than others. This would mean that the sample is not representative of the entire population. Bias can cause misleading conclusions about the population that you are studying. In example number one, Robin is trying to determine the average height of the students in her high school. Since there are many students in the school, Robin will need to select a sample of the students to survey. Determine if the following samples are biased or unbiased. Okay, so remember that we want to avoid bias when we're choosing our sample because biased samples are not representative of the entire population. Because there are so many students in Robin's school, it's going to be tough for her to get the height of every student. So again, she's just going to try to select a representative sample of the students in her school. So question A, what if the sample that Robin chose was the basketball team? Would this be a biased sample or an unbiased sample? Okay, well, actually would be a biased sample. That is a biased sample. And the reason why is because not every member of the school population is on the basketball team. Remember that you always want to try to have a random sample where every member of the population has a chance of being selected. If you only chose members of the basketball team, you're leaving out a large section of the entire school population. Letter B, what if our sample was all girls? Okay, well, this example would also be a biased sample. And the reason why this one is biased is because not every member of the school population is a girl. So we're going to be leaving out all of the male students. So that would be a biased sample as well. Letter C, what if our sample was every 10th person chosen from an alphabetical list of all students? Okay, well, this actually would be a really good sample. This is an unbiased sample. Okay, so it's every 10th person, so it's random, and it's an alphabetical list of all students. So every student has a chance of being selected for this sample. Every 10th person chosen from an alphabetical list of all students is an unbiased sample. Every fifth person chosen from an alphabetical list of all boys. All right, every fifth person, so it starts out nice and random. It's from an alphabetical list, but it's only a list of boys. Not every student in the population is a boy, so we're going to be leaving out a portion, meaning that this is a biased sample. Letter E, every fifth person chosen from an alphabetical list of each homeroom. Okay, so again, we want to know if this is an unbiased sample or a biased sample. So we're going to be taking every fifth person, so it sounds random. It's from an alphabetical list of each homeroom. Okay, so remember that we're trying to get the average height of students in Robin's school. Every student in the school has a homeroom. And again, it's random here. This sounds like a good sample as well. This one would be unbiased. Everybody in the school has a chance of being selected for Robin's survey. Example 2 asks us to do explain how the outcome of the survey might be affected if Robin did use the basketball team as her sample. Okay, so if Robin went and selected the students on the basketball team, how might that be a bad sample? Okay, so how might the results be affected? Well, basketball players are generally very tall, so we can start by saying that. Basketball players basketball players are usually tall. Okay, so anybody that would be looking at Robin's results, all right, somebody might think that all students in Robin's school are tall. Okay, if you only take the heights of the basketball players and said that this is representative of the entire population, then someone's going to think that every student that goes to that school is tall. So again, that would be a bad sample to use. It would be a biased sample, and it is not representative of the entire population. Example 3 tells us that a researcher chose a random sample of registered voters in Kentsville. He found that 3 out of 5 voters said that they would vote for Miguel Miller for mayor. Question A asks, is this sample representative of the entire population? And to explain our reasoning. Okay, well, we're looking here that the researcher chose a random sample, so that's good. And it's a sample of registered voters. And he's trying to figure out who they want to have for their mayor. So I think that this is a good representative sample. Yes. This sample was chosen randomly. This sample was chosen randomly. So each member of the population, had the same chance of being selected. Every member of the population had the same chance of being selected. So again, when your sample is completely random like this, everyone has the same chance, then it's going to be a representative sample. Now, question B asks, if there are 800 eligible voters in Kentsville, predict how many people will vote for Miguel Miller. Okay, so again, the researcher didn't want to ask all 800 people. That might take too long for the researcher to do. So based off of the smaller sample, the researcher found that 3 out of 5 voters said that they would vote for Miguel Miller. Okay, so we can set up a ratio here where the numerator is going to be that they will vote for Miguel Miller, and in the denominator, it was the total. Okay, so our ratio would look like 3 out of 5, 3/5. 3 of the 5 total people said that they will vote for Miguel Miller. We're going to set that equal to another ratio where there's a total of 800 eligible voters. And we have to figure out how to scale from 5 up to 800. Well, if you do 800 divided by 5, that gives you 160. So 5 times 160 gets us to 800. So we'll do the same thing in the numerator. 3 times 160. And that would give us an answer of 480. Okay, so we can say that about 480 people will vote for Miguel Miller. Okay, and again, this is just a prediction based off of the probability from our sample that we did up here, where 3 out of 5 voters said that they would vote for Miguel Miller.